Hello everyone, welcome to Digital Communication Tutorials. In this video, I am going to take up the 8th numerical on digital modulation techniques. Please note, this is a numerical on quadrature phase shift keying. Let me read out the question first. In a QPSK modulation scheme, the input binary sequence BI is equal to 1100, 1011, 101. The bit interval is TB. Give the demultiplexed sequence BEI and BOI. Assuming NRZ polar format, sketch the sequences BI, BEI and BOI. Please note, BI is our input binary sequence. BEI is a sequence that is derived from the input binary sequence BI by selecting the bits which are in the eventh position. In a similar way, BOI is a sequence derived from the original binary sequence BI by selecting the bits that are placed in the odd position. So, from the input binary sequence BI, we can create BEI as well as BOI, and that is what I will be showing you now. Let us start with the solution part here. I am going to start by writing the given input binary sequence BI. It is 1100, 10, 111, 01. If I have to give the location numbers, then I would start with the leftmost bit and I will call this as B0. The next one is B1, the next one is B2, the next one is B3, and I continue in this fashion. Right. So, totally we have 11 bits. As I said, BEI is the sequence of bits that are derived from the original input binary sequence by selecting the bits that are placed in the eventh position. So, BEI will be B0, B2, B4, B6, B8 and B10. This is our even numbered sequence. So, I will write the values for the corresponding bit locations here. It is 1, 0, 1, 1, 1, 1. In a very similar fashion, let me now write the odd numbered sequence. It is BOI and it is derived from the input binary sequence BI by selecting the bits that are located at the odd numbered positions. That is, it would be B1, B3, B5, B7 and B9. Let me now write the values for the corresponding bit locations. B1 is 1, B3 is 0, B5 is 0, B7 is 1, B9 is 0. Right. So, these are our demultiplexed sequences. Moving on to the next part of the question, we are asked to sketch the demultiplexed sequences BEI, BOI as well as our input binary sequence BI. We are also asked to assume the NRZ polar format for symbols 1 and 0 respectively. It should be noted that for the binary input sequence BI, the bit interval is equal to 1 TB seconds. On the other hand, for both BOI as well as BEI, the bit interval is equal to 2 TB seconds. This means that when I am sketching the waveform for BI, every bit of the input binary sequence should be treated as of length 1 TB, whereas a bit from either the odd numbered sequence or even numbered sequence should be treated as if it is of length 2 TB seconds. Right. With that, now I will start sketching the waveforms. I will start with the input binary sequence BI first. Since the input binary sequence has 11 bits, I will have to now divide the x-axis into 11 bit intervals, and that is what I will be doing now. Please note the x-axis is time axis, and here every bit interval is of length 1 TB. Now, I will write the values of the x-axis. This would be TB, this is 2 TB, this is 3 TB, and it continues in this fashion. In the next step, I will write the input binary sequence values across each bit interval. Now, I will start plotting the waveform assuming the polar NRZ representation scheme. In the polar representation, a symbol 1 is represented by a positive pulse of duration 1 TB, and a symbol 0 is represented by a negative pulse of duration 1 TB again. Let the amplitude of these pulses be denoted as A and minus A respectively. The first bit here is a symbol 1. So, I will transmit, let us say, a amplitude of A for 1 TB duration. The next bit is also 1. So, I will continue transmitting the same amplitude for the next 1 TB duration. The third bit is a bit 0, and a bit 0, as I just said, is represented by a negative pulse of amplitude minus A and duration 1 TB. So, I will now change the amplitude from plus A to minus A, and I will transmit the amplitude of minus A for 1 TB duration. The next bit is also bit 0. So, I will continue transmitting minus A for the next 1 TB. The next bit is a bit 1. So, change the amplitude from minus A to plus A and transmit plus A for 1 TB. The next bit is also bit 1. So, continue transmitting the same value. Next bit is 0. Change the amplitude from plus A to minus A and continue transmitting minus A for 1 TB. The next two bits are bit 1. Change the amplitude again and transmit plus A for 2 bit duration. Next bit is 0. Send a negative pulse of amplitude minus A and duration 1 TB, and the last bit is a bit 1. So, transmit a positive pulse of amplitude A and duration 1 TB. This is the waveform for the input binary sequence using NRZ polar format. Let me now move on to the next sequence, which is even numbered sequence. Right. For sketching the even numbered sequence, as I previously said, you are supposed to take one bit and sketch the same for 2 bit durations, that is for 2 TB. So, I have to now divide the x-axis for every 2 bit durations. Let me now do that here. Let me now write the sequence itself. The BEI is given as 1, 0, 1, 1, 1 and 1. This is our even numbered sequence. Please note, we have drawn the x-axis for 11 bit intervals in my previous diagram. However, here every bit is of duration 2 TB. So, now the x-axis should be of even numbered intervals. So, for that I am going to make a small modification here. I am going to introduce the 12 TB point as well. Right. The last one here, this would be the 12 TB point. So, this is where our sequence is supposed to end. With that, let us now start plotting the waveform. The first bit in BEI is a bit 1, and in the polar form bit 1 is represented with a positive pulse. However, please note this is BEI sequence. So, every bit has to be drawn for a duration of 2 TB. So, for the first 2 bit durations, you have to transmit a positive pulse of amplitude, let us say plus A. Next bit is a bit 0. So, change the amplitude from plus A to minus A and transmit minus A for 2 bit durations. The next 4 bits are all plus 1. So, I will simply change the amplitude from minus A to plus A and continue transmitting a positive pulse for the next 8 bit durations. This is the waveform for the even numbered sequence BEI. In a very similar fashion, let me very quickly show you how to plot the odd numbered sequence. Right. The odd number sequence is given by 1 0 0 1 0. Please note, I am writing these sequences in the corresponding bit intervals. Let us now start sketching the waveform. The first bit is a bit 1, so transmit a positive pulse of amplitude plus A and duration 2 TB. The next bit is a bit 0, change the amplitude from plus A to minus A and transmit a pulse of amplitude minus A for 2 TB. The next bit is also bit 0, so continue transmitting minus A for the next 2 TB durations. The next bit is a bit 1, change the amplitude from minus A to plus A and transmit plus A for 2 TB durations. The last bit is a bit 0, so change the amplitude of the pulse again and transmit a pulse of duration minus A for 2 TB durations. This is the sketch of the odd numbered sequence BOI. Right. With that, we come to the end of this video. If you like this video, kindly like and share this video and subscribe to my channel for more information on digital communication. Thank you for watching. Have a good day.